Okay, friends, let's figure out how to do this average, otherwise known as expected value. They're pretty straightforward. The words might look a little terrifying, but it's actually pretty straightforward. All you got to do is, for any experiment like this, where you've got a whole bunch of things that can happen, you figure out what's the payout for each thing, and then what fraction of the time do those things happen. You multiply each payout by the fraction of time it happens, and then add them all together. Pretty straightforward. In this case, since we're rolling a die, there are 6 different things that can happen. 6 different things. So if we roll a 1, this is game number 1. You're going to do game number 2 in the next question. In game number 1, if you roll a 1, you get 1 candy as a payment. And you multiply that by the rate of the time that you roll a 1. And that's 1/6 of the time. You saw some percentages from the simulator that I ran, and they were all right around, as I said, 16.66666%, which is 1/6 as a fraction. You don't want to use 16.7 or 17% to do math on. You want to change it either to a fraction or a decimal, and I think the fraction's easier to use in this case. Then we have to add to that, what happens if you roll a 2? Well, you win 2 pieces of candy, and that also happens 1/6 at a time. What happens if you roll a 3? Well, you get 3 pieces of candy. And that happens 1/6 at a time. And all the rates are going to be 1/6 on this one because you're rolling a die. And the whole point of a die is that all 6 sides show up equally, which would be 1/6 at a time. In the homework later on, you're going to see ones that don't happen equally, and they're more interesting, but also it's easier to deal with this at first. And we just keep going. Then we have to add in 4, which is what happens if you roll a 4, you win 4 pieces of candy, times a 1/6, and you just keep going. 5 if you roll a 5, and 6 if you roll a 6. And then all you got to do is just figure this out mathematically. And you got a couple options. You can run it into Google if you want to. Type the whole thing in and just press enter and it'll tell you what it is. Or we just do it manually. So this is 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. That's going to be 21/6, which is 3.5. On average, you're going to get 3.5. And that should make sense for a whole bunch of reasons. Number 1, it sounds an awful lot like the answer you got up above. And number 2, if all the prizes are 1, 2, 3, 4, 5, 6, and all those prizes happen at the same rate, shouldn't the average be right in the middle? Now, realize the only reason the average is right in the middle is because all of these rates are the same. This won't happen in every experiment, for example, the ones we'll look at later. But for right now, that average should make a whole lot of sense. Okay, you try game number 2.